Hello, and welcome to this session. Learning outcome, LO3, understand different types of chemical bonds. Today, we will learn how atoms achieve stability through bonding. Why understanding chemical bonds is key to grasping the stability of atoms. The different types of chemical bonds: ionic, covalent, and metallic. This session will explore how atoms interact to become stable, the rules that govern these bonds, and examples of each type in real life. Ionic bonding involves the transfer of electrons. It typically occurs between metals and nonmetals. Metals lose electrons, forming positive ions, while nonmetals gain electrons, forming negative ions. Sodium and chlorine form ions by transferring electrons, achieving full outer shells. The resulting electrostatic attraction forms a strong ionic bond. Ionic compounds have high melting and boiling points due to strong ionic attractions. They dissolve in water as water molecules separate the ions. When molten or dissolved, ionic compounds conduct electricity. In solid form, ions are fixed, preventing electrical conduction. The giant ionic lattice explains these properties. Metallic bonding involves delocalized electrons. Metals lose outer electrons, forming positive ions in a lattice. Delocalized electrons move freely, creating a sea that holds the structure. The electrostatic attraction between ions and electrons forms the metallic bond. This bond explains metals' unique properties. Metals conduct electricity due to mobile delocalized electrons. They are also good heat conductors for the same reason. Metals are malleable and ductile as layers of ions slide without breaking bonds. High melting points arise from strong attractions in the lattice. These properties stem from metallic bonding. Dot-cross diagrams illustrate electron involvement in bonds. Dots represent electrons from one atom, crosses from another. These diagrams show electron transfer, sharing, or delocalization. For ionic bonds, they depict electron transfer and resulting ions. For covalent bonds, they show shared electron pairs. Sodium chloride is a classic example of ionic bonding. Sodium has one outer electron, while chlorine has 7. Sodium transfers its electron to chlorine, forming sodium ion positive and chloride ion negative. The diagram shows this transfer, resulting in full outer shells. The ionic bond is the attraction between sodium ion positive and chloride ion negative. Covalent bonding involves electron sharing. Each hydrogen atom shares one electron to achieve a full outer shell. In a hydrogen molecule, the shared pair forms a covalent bond. Oxygen shares electrons with hydrogen in water, forming OH bonds. These bonds involve shared electron pairs attracted to nuclei. Water is an example of covalent bonding. Oxygen has 6 outer electrons, while hydrogen has 1. They share electrons, forming OH bonds. Each bond is a shared pair of electrons, one from hydrogen, one from oxygen. Oxygen ends up with 8 outer electrons, achieving stability. Metallic bonding in sodium involves delocalized electrons. Sodium atoms lose outer electrons, forming positive ions. These electrons become delocalized, moving freely between ions. The diagram shows this electron sea around sodium ions. The metallic bond is the attraction between ions and electrons. Dot-cross diagrams simplify bonding concepts. They show ionic bonding as electron transfer. Covalent bonding appears as electron sharing. Metallic bonding is depicted with delocalized electrons. These diagrams provide a clear visualization of atomic interactions. Electrostatic attraction is central to all bonding types. In ionic bonds, it's between oppositely charged ions. Metallic bonds involve attraction between ions and delocalized electrons. Covalent bonds feature shared electrons attracted to both nuclei. This attraction underpins bond strength and properties. Atoms bond to achieve stability. Ionic bonds result in full outer shells for ions. Covalent bonds share electrons to complete outer shells. Metallic bonds maintain a stable electron C. Each bond type contributes to atomic stability. Bonding type affects conductivity. Ionic compounds conduct when ions move freely. Metals conduct due to mobile, delocalized electrons. Covalent compounds generally don't conduct electricity. Conductivity links directly to electron movement in bonds. Melting points reflect bond strength. Ionic compounds have high melting points due to strong ionic attractions. Metals also have high melting points, thanks to metallic bonds. Covalent compounds vary. Depending on molecular interactions, bonding type dictates energy needed to break bonds. Solubility depends on bonding. Ionic compounds dissolve in water as ions separate. Covalent compounds' solubility varies with polarity. Metallic bonds generally don't dissolve. Bonding type influences interaction with solvents. Metals are malleable and ductile due to metallic bonds. Layers of ions slide without breaking bonds. Delocalized electrons maintain structure during deformation. This property allows metals to be shaped and stretched. Malleability and ductility stem from electron mobility. Visualizing bonding aids understanding. Dot-cross diagrams simplify electron interactions. They clarify differences between ionic, covalent, and metallic bonds. Visual tools enhance comprehension of atomic stability. Understanding bonding is crucial for chemistry. Bonding knowledge applies to material science. It explains properties like strength and conductivity. Industries use this understanding for designing materials. Bonding insights inform chemical reactions and processes. Real-world applications rely on bonding principles. For deeper insights, refer to recommended textbooks. Chemical Principles and Inorganic Chemistry are excellent resources. Journals and ebooks provide advanced knowledge. Explore these materials for comprehensive understanding. Continued learning enhances mastery of chemistry. In summary, ionic bonding involves electron transfer, while metallic bonding features delocalized electrons. Both bond types explain the properties of the substances formed. Understanding these bonds is essential for grasping material properties. For any inquiries, please contact us on WhatsApp at 07-48436-1688. We appreciate your attention and look forward to the next session.